this will be the video for Learning Log 3, and it will go from pages 23 through 39. So on page 23, we have the definition of prime numbers and composite numbers. Then on page 25, we have the definition of twin primes, relatively prime numbers, determining whole numbers of divisors, and then over here we have an example of relatively prime numbers. And then you have categorizing natural numbers, abundant and deficient numbers. And then over here there is a foldable of abundant, deficient, and perfect numbers. Then on page 27, you have the definition of the prime numbers of the sieve, and then you have the definition of factor and multiple, and then you have an example over here showing factors and multiples. And then you have some examples of the linear model, the rectangular model, and over here there are some more examples of the linear and the rectangular model. Then at the bottom there's finding factors and multiples using the Cuisenaire rods. And then on page 29 it continues with how to find with the Cuisenaire rods, and then it goes into the greatest common divisor and the definition and the different methods of finding the greatest common divisor. So the colored rods method, and there's an example over here of the colored rods method, and then prime factorization and the intersection of sets. And then it goes on at the bottom to start with least common multiple, and then over here there is prime factorization tree and another prime factorization example. Then on page 31 it goes on to the number line method and different methods and the color rod method to find the least common multiple and the definition, and prime factorization as well for the least common multiple. And then there's an example of the least common multiple using the colored rods from my activity book. And then also the intersection of sets, there's an example, division by primes, and over here there is an example from my activity book, division by primes. And then it goes on to the greatest common denominator and least common multiple products. And then on page 33, it starts with integers and the definition of integers and what you can use to represent them, the black chips and red chips. And then it goes on to the models of integer addition and the different methods, and the number line model and the pattern model. And then at the bottom it goes on to the definition of absolute value. And over here we have an example from an activity book of the number line model, the pattern model, and then a foldable of examples of the absolute value of some numbers. And then at the very bottom it goes on to properties of integer addition and the closure property. And then on page 35 it goes on to describe the rest of the properties, the commutative property, associative property, identity element, additive inverse property, and then the definition of the theorems of integer addition. It gives the rule, and then it goes on to the subtraction of integers, models, some more models, the black and red chip, the number line, the charge field, and the pattern. And then it goes on to the missing addend model for integers, and there's an example, and then to the side we have another example of the missing addend and an example of the pattern model. And then on page 37 we have the multiplication of integers and some different models for it. We have the chip model, the charge field model, the number line model, and then to the side I have an example from my activity book of the chip model, and then another example of the number line model. And then at the bottom, the definition of the pattern model and an example, and there is a definition, an example of the pattern model. And then on page 39 we have the properties, the closure, commutative, associative, multiplicative, identity property, distributive property, and then the zero multiplication property of integers. Then it goes on to the theorems of integer multiplication and the algorithms and the pattern model. And over here we just have some examples of positive times positive integer, positive, negative, negative times a negative, and then the same for division. And then a little example from my activity book of division of integers. And on page 41 it wraps up with the set and the repeated subtraction examples and the algorithms of division. And then over here is an example of the repeated subtraction for the division of integers, and that ends on page 41.